Right? Are we recording?
Are we
We're meant to be
recording?
recording now. I don't know. Did you press the button?
What? I see squiggly lines.
Oh, squiggly lines are good. I guess that means
Oh, dude, we're recording. Every time.
It begins another episode.
People, you are in for a treat. Let me tell ya.
It's gonna be a good one. It's gonna be a good one. Welcome back.
Welcome back to the next episode of our show.
Yes, this is the show that we're calling The Nerd and the Scientist, or The Scientist and the Nerd, presented by Science Actually.
Science Actually. Today's episode is In the Face with Space.
In the Face with Space. Yes, we have to give a big shout out and thank you to Benjamin's sister for providing us with a list of alternative show names, which will now become a list of names that we will be using for each episode.
Oh, thanks, Dink.
It's great. That's great. Space in the Face.
Space in the Face.
In the Face.
In the Face with the space.
I feel like we could just do 30 minutes of that.
We could. All right, guys. Sit down and relax. Here we go. Space in the Face.
Buckle up and buckle in, because this is all we got.
Kovi and Benjamin talking about space and face.
Space and face, yes. Oh, gosh. Our actual topic for today, for this evening, for this morning, depending on which time zone and which celestial frame of reference you're listening to this episode in, is somewhat to do with space, not so much to do with face, I guess.
Nope. Has a lot to do with space.
A lot to do with space.
I hope.
We're going to talk.
Otherwise, we've completely branded this wrong. Anyway, so back to textiles.
Back to textiles. We'll also be talking about whales, maybe briefly, just very briefly.
Why not?
Yeah, we'll talk about whales. We'll talk about dwarves. We'll talk about Pluto, the dog. No, not the dog. The other one.
Pluto, the planet. Take
Right.
that, Neil deGrasse
Or is it a dwarf planet?
Just a planet.
I do love. I mean, you've seen Mike Brown, the astronomer on Twitter or Blue Sky.
Yeah.
Yeah, Pluto Killer is his handle. For anyone who's wondering. So there was actually a paper that came out of two universities in Japan recently that they claimed that they might have found a ninth planet in the solar system hiding around in the Kuiper Belt. So I tagged Pluto Killer in that, and I'm curious what he has to say, because maybe it's kind of like conservation laws in science. If you get rid of one planet, you have to come up with another one. So maybe we'll have 9 planets again. We'll have to come up with another mnemonic to remember all the names.
I don't remember the mnemonic to come up with all the names. I remember it for Jupiter's Galilean moons. I eat giant cookies.
I eat giant cookies. I love that. I've never heard that before.
That's what I grew up learning, and that's how it's the Galilean moons in order from proximity to Jupiter and further out. So Io, Europa, Ganymede, Callisto.
Is this proximity at closest approach?
No, just which one's closest to Jupiter?
Average proximity.
Average proximity.
Yes.
Yeah, they don't cross.
Oh, wait. No, they don't cross paths. But it's always a thing, when people say, what's the distance to celestial object X? Like with the moon recently, with this whole blue supermoon that everyone was so excited about. It's like, well, it all has to do with the distance of the moon, between the moon and the Earth. But it's like that distance changes. Mm-hmm. And that's the whole thing.
Yep.
It's all of it.
It's all of it.
But yeah, we can talk about the blue supermoon and the name maybe for this potential new planet that was found in the Kuiper Belt, otherwise known as a TNO, a trans-Neptunian object. We can talk about that a little bit later. But the main story today,
bring it, Kovi.
The crux of the matter. Yeah,
lay it down.
Let's rip the Band-Aid off. Lay it down today.
Not tomorrow.
This Sunday.
Right now.
Today.
Yes.
2 men talking about classifications.
Oh, God,
Classification.
I got goosebumps. I got goosebumps. I like talking about classifications.
It's wonderful. I mean, it's amazing like how little we cared. I don't know about you, but I cared about like classifications as a kid, especially things like the Dewey Decimal System or the classification system used in libraries. Didn't matter to me. Point me to where the book is that I want. That's it. I don't care. But as a scientist and also as a nerd, it's kind of important, right? Like we have to know these things and what categories they fall into. I think, though, the main thing is that this is kind of problematic, right? Because the categories are only as good as the people who come up with them.
Yes. Right. Which segues nice into my little complaint section coming up next. But continue.
I'm curious what this complaint is. But, I'd like to complain about people complaining about people complaining about people complaining. It's about time something was done about it. For all you Monty Python fans in the audience, all three of you. I think that the issue is that, people are concerned, whether it be with Pluto or with a more recent article that came out about stars and planets and, whether there is a blurry line between them. I mean, it all comes down to the way that we choose to set up these classification systems, right?
Yep.
So, like, if you were to come up with the main differences between a star and a planet, and don't say one is hot and the other is not, that doesn't count. What would be, like, the main difference to you?
Between a star and a planet?
Yeah.
I would think that a planet is something that goes around a star, and a planet does not give off, I believe, its own light.
Mm-hmm.
And then if you want to get into the whole IAU classification of what is a planet, it also has to have cleared its path of debris, and it has to have a round-ish shape from its own gravity. But I think you're talking, but that's...
Oh, no, that's super relevant. That's definitely relevant. I think, and that kind of goes into the whole thing with Pluto, right? I guess, yeah, with stars versus planets, what you're saying definitely makes sense. The issue is that it's also possible for planets to give off light, right? I mean, there's... and my office mate just walked in. Wonderful. But yeah, no, like the whole issue is that when you talk about giving off light, how much light are we talking about, right? Because you will always have thermal radiation that comes off any body that doesn't have a zero temperature. And in some cases, as if you remember, like we discussed once, brown dwarfs can be very damn cold. They can be, colder than an oven that you have here on Earth. And there are some planets that have extremely high surface temperatures. I mean, look at Mercury, look at Venus.
Is that where the planet-star line blurs when the light that is being given off is no longer visible light, but instead is like radio light or infrared light? And that's where just the blurring line begins. Because I'm sure Jupiter gives off its own light on a certain spectrum.
It also gives off radio light.
Right. And it also radiates heat back a little bit.
Yeah. So I think that's generally not the classification system that's used. I think for the most part, astronomers historically have spoken about how massive something is.
Right.
Right. And they normally say that if it has more than 80 times the mass of Jupiter, it's a star. Less than 13 times the mass of Jupiter, and it's a planet, a giant planet. But that in-between range is kind of where the brown dwarfs sit. And this was the whole point of the discussion. The idea for having that mass limit is if you have enough mass to fuse hydrogen, which makes you, do star-like things. Problem is that you can lose mass or gain mass over a lifetime.
Right.
So that classification system also kind of doesn't work.
Huh.
Everything's broken, and we
So
don't
we
know
should
what
just name everything space stuff and just be done with it.
space stuff.
There you go. I live on
It's
some
very
space stuff, and
Carl
there's some bigger
Sagan-esque.
space stuff out there, and smaller space stuff orbits the space stuff I'm on, and I go to the beach and get warmed by the big glowing space stuff and space stuff.
So you're saying who needs classifications anyway?
Yeah. No, we need classifications.
So I think the best way that people get around this issue is just looking at how these objects form, right?
Okay.
Because the way that a planet forms and the way that a star forms are different,
Right.
right? Stars form by collapsing clouds of gas like hydrogen in space. As they collapse down, the hydrogen is under more and more pressure from gravity. It ends up causing them to fuse into heavier elements like helium, and then to higher elements, fuse into helium. Whereas planets tend to form from like this rocky debris disk that forms around a star, like the leftover material that doesn't go into the fusion. And brown dwarfs, I hate to say it, are failed stars. They're like a star that formed like a star that just didn't have enough mass to
Is the
do
term
fusing.
failed star kind of like not a popular term? Is that more of like a TV term for people like me? Because I understand the concept of failed star. It's an object that didn't gain enough mass in its formation to ignite. Right? I get the idea of that. But does that ruin the classification of things?
I think it still falls into, it's like a subcategory of star. It's more of a star than a planet.
Is it?
But yeah, I think so. But again, it all comes down to the definitions, right?
Right.
Wait, I'm curious. What was your complaint about the IAU?
The Pluto thing. The Pluto thing. Pluto's a planet. Pluto is a planet. It is. It is. It absolutely is a planet. The requirements to become a planet is it has to be round from its own gravity. It has to have orbit a star, and it has to have cleared its orbit of any debris. But in this epoch that we live in right now, human beings have made these rules, and at this particular time that these rules are made, Pluto has not yet had the time necessary to clear its path because it's so incredibly big and it goes around so slowly. It hasn't had the time yet. Mercury's had the time, Venus has had the time, Earth's had the time. But, if these rules persist, that means in just, I don't know, however many more, couple dozen orbits, I'm sure more than that, Pluto will clear its path and it will become a planet because it will have finally satisfied the last requirement that we set up here in 2010 or whatever it was when they did it. Right?
Interesting.
So
Interesting. Because not only the human-made rules, it's also the timescales that the human-made rules are applied on.
Right. Earth wasn't a planet by these rules. Jupiter should still not be a planet because of the Trojans that follow it and precede it around its orbit.
Damn
right
those
now.
Trojans. Those sneaky Trojans.
Neptune's orbit crosses Pluto's orbit. That's some pretty significant debris. So both Neptune and Pluto should not be planets because there's something in the way. And when the vote came up in the IAU to agree that these were the classifications to make what is and what is not a planet, they did it at the very last day of the convention that year, after which most of the attendees had left. And so they asked the people in the room who's left, a smaller, much more easily bribed group of people, say, what is a planet? And they agreed just to be spiteful to Pluto in its name. And then we discovered, and this was done while New Horizons was on the way. And then after they voted that Pluto is not a planet, New Horizons breezes by, and we see a beautiful planet with an atmosphere and mountain ranges and its own moon system, and it's beautiful. So poo-poo you, IAU. That's a t-shirt.
Well, you heard it here first.
You heard it here first.
IAU. Yeah. This is the official position of this podcast. We are poo-pooing the IAU.
That's what I wanted to complain about. I am done. Now you, sir, with an actual degree in significant education, please continue.
I like that. I like the idea that they just waited to the last day of the conference for all the delegates from Pluto, or at least all the delegates who
Are all the
gave us-
Plutonians gone? Are they gone? Are they gone? Good. Let's talk about them.
Or better yet, it's like the New Horizons probe is on the way to the planet, and meanwhile they've decided it's not a planet, so New Horizons gets there. It's like, nope, nothing to see here. Nope, let's just
Probably
keep
why
going.
it sped by so fast.
All right, I guess this would be a great time to put our ad segment in. For those listening, our ad segments are kind of a work in progress at this point.
All right. What's our ad today? Not the rubber duck.
Rubber ducks were the content that we were selling last week. This week, I was thinking what we could do is talk about two fantastic sets of nerd-related playing cards. How does that sound?
Are they out for real?
Oh, it's a real thing. It's a real thing.
I thought we were just making up stuff.
Oh no, this is real. And it happens to be on my desk.
Quantum playing cards.
Quantum playing cards, QED playing cards, and they've got quantum equations in the back. The cards themselves, incredible. They are both there and not there as you try to
playing cards with quantum equations in the back. They sell themselves, people. It's a perfect holiday gift for everybody. There's no greater way to say I love you than the gift of quantum equation playing cards. Can't think of what to get grandma this holiday season? Quantum playing cards. She'll love them. She'll put them in the same box with the recipes for cookies. Quantum playing cards.
And they'll both be in that box and not be in that box at the same time. They are pretty cool though.
A gift that keeps on giving or doesn't.
Or doesn't. No, what is cool is they've got different physicists for all the face cards. So that's Bohr, Marie Curie, and they've got like little tidbits, little Easter eggs on each of the face cards for you to try to figure out who's who. We got Feynman as the king of spades over here with his bongos.
What's that in the middle? Is that Fortran or something?
The Fortran.
Or some kind of punch card?
It could be a punch card, yeah. There are Feynman diagrams. Anyway. Definitely a fun card for...
Richard Feynman was the man.
I love how in Oppenheimer, sorry, spoiler alert for people who haven't seen it yet, switch off this podcast right now and then switch it back on. But I love how people are all hyped up about how it's like the Avengers assembling for all of these physicists in Oppenheimer. And the reality is most of them, especially Feynman, get like almost no attention, no lines. But they made sure to have Feynman playing his damn bongos. That had to be in the movie.
That's awesome.
The most important part. Yeah, that's what typifies him. It was great. But yes, quantum playing cards for kids of all ages, for adults of all ages, for middle-aged people of all middle ages. Get them now while they're both there and not there.
I love it.
That's great. And back to the episode. So this
back
is
to the episode. Hey, Kovi.
Yeah, Benjamin.
Can a star ever stop being a star and turn into a planet?
Funny you should ask that. The answer is no.
Oh, okay.
Although it depends on how you.
I read an article
things.
for nothing.
I was interviewed for that article for nothing. Gosh.
Kidding.
No, it can definitely change its appearance if it loses mass, it cools down. You can, things can change in how they appear. But the formation history is always going to be the same. It's always going to be the way that it formed. It formed like a star. It formed like a planet. And you can't change that, can you?
So,
yes. You look puzzled. Yes, you in the back.
Question from somebody who did not go to astrophysics school. You can tell because I can't say the word. Can a star...
Mm-hmm.
I know a star can die, and I know it can shed its outer layers, and it can explode, and it can leave behind a core, and over a long period of time, that core can cool down, and it's a smaller thing.
Mm-hmm.
And it could get to a point where it's cool, and it doesn't really emit light. I'm assuming it's still going to be a star. It's never going to be.
Yeah.
It's never going to be planet-like or planet-ish. It's a stupid question.
So it's a great no. That's not a stupid question at all. That's a really great question. And don't worry about your pronunciation of astrophysics. At least you didn't say astrology. That's fine. So yeah, what you're actually describing is this thing called, I believe they're called black dwarfs. Now they're still theoretical. So you've heard of a white dwarf, yes?
Yes.
Great. Right, so white dwarfs are these collapsed, kind of dead cores of sun-like stars that only have, a couple solar masses or less. And, eventually they stop doing nuclear fusion, so they have nothing producing heat and energy, and then they're just, slowly dying and slowly giving off heat, right? And you're asking, okay, so what happens when a white dwarf eventually loses all of its heat? So that theoretical state is called a black dwarf, and it would be black because it's not giving off any thermal radiation even at that point. The problem is we haven't seen one, and it doesn't seem likely that we will because the cooling time is roughly...
There hasn't been enough time for it to happen yet.
Bingo. Yes, exactly. So the amount of time it would take to completely cool and lose all of its residual heat is roughly, the same age as the universe, or in some cases, it's longer than the age of the universe. So we are not likely to find black dwarfs anytime soon. We're also not likely to find them because they're quite difficult to detect, given that they don't give off light. So we would have to find them in some other way, either because they're in a binary system and they're exerting a gravitational pull on the other object, or potentially if we get really good at micro lensing, seeing the way that space can be warped by small objects, and then the light traveling through that space. But yeah, no, that's a great question. Okay. Well, yeah, we're going deep this episode.
We're going deep. So if we have a binary system and the primary star is very massive, it's the center, and there is a second star orbiting around the main star along with other planets, it's possible, right? And that secondary smaller star, can it run out of fuel and begin its cool down process and become a kind of very hot planet that's orbiting with the other planets? Or that's still going to take way too much time for that to even be considered?
It would never become a planet, right? It would, if we're talking about this secondary star being, a sun-like star, so, one solar mass or two solar masses, it would, its end state would be a white dwarf. But what you're describing actually is a surprisingly common situation in the universe, because what happens if, the white dwarf does its thing and it becomes a white dwarf, so there's no nuclear fusion happening, right? And it's basically just this residual heat giving off a bit of light, but it's next to a really massive companion star. I love that. Benjamin's typing in the chat. He's like, I'm getting this right. I love it. Yes. No, absolutely. You're spot on with this. Really good intuition. So what happens is eventually you can end up in a situation where the white dwarf pulls mass off the other more massive companion in the binary. But it's dead inside, and it can't actually sustain nuclear fusion. So once it gets too much mass, it will eventually collapse and form what's called a type 1a supernova. And we can do a whole episode on the classifications of type 1a supernova, but basically speaking, the classifications are either you have a massive star that's much more massive than the sun that collapses when it's, burning heavier and heavier things, and once it hits iron, there's not enough material to continue burning, and then it eventually collapses inwards and explodes outwards, and it's a wonderful, fun light show. But a type 1a supernova is not a core collapse. It's basically the result of a white dwarf in a binary pulling material from its binary companion and pulling too much material. So once it goes to about 1.4 times the mass of the sun, its own gravity, like it's basically a white dwarf is held up by subatomic particles, or trying to push outwards, right? Because these particles cannot sit in the same place. It's called a degenerate star, which sounds more judgmental than it really is. But yeah, so so basically this quantum degeneracy that's pushing outwards can only push so much. And so if you get too much mass on top of that degenerate star, it will eventually collapse. And so yeah, so that's a type 1a supernova.
That's awesome. I never thought of that. And in the binary system, the smaller star orbiting the bigger one could be the one that goes supernova.
Yeah.
That would wreak havoc, I would assume, on the binary star.
Yeah, and it wouldn't be much fun for any life on those planets orbiting around that.
Those poor people on Tatooine.
I know. Probably the worst thing that had ever happened on Tatooine.
Probably.
Oh,
yeah.
Man. But yeah, the supernova classification system is a whole other... Honestly, we could do a whole episode on it. But it fits in really well with this topic, because the way that we classified supernova is also coming into question recently. Because it's originally we would classify it depending on whether or not there was helium or hydrogen in the spectra that we would get, right? When you break down the light that's coming from it, you can figure out what the chemical composition is. And then now they're realizing that there are so many other subtypes. It's not just, type 1 and type 2. There's type 1A, B, C. There's, type 2P and 2N and 2B, all these different variations, because, again, it's an issue when we only see two types of things. And so we say type 1 and type 2, but nature is on a spectrum. There's so much more. There's, we can't just fit things into neat little boxes.
Excellent. This is precisely why the hot dog is not or is a sandwich debate exists.
The hot dog is a taco.
No, it's not. See,
it's a taco.
Either everything is a supernova or it's not. But there's so many kinds of supernovae. There's type 1A, 1B, 1C, and I'm sure there's type 2 and whatever other classifications. Same thing with hot dogs. Same thing with hot dogs. They're either all sandwiches, people, or you got to explain a little more. You got to break it down a little more, like in nature.
Is this like that thing where people say that everything in the universe is either a potato or not a potato?
What? That's technically true.
That's technically true. It's epistemologically silly, but it's technically true.
Technically, it's true. I designed a lovely little T-shirt. It has a map of the solar system, and it shows you where all the tacos are in the known universe. Right? Only in one spot that we know of. So technically, yes. Yeah.
Oh man. I think this is a wonderful note to end on.
I'm good with that.
I think we covered most of the things.
Where all the tacos in the known universe are.
We should classify planets on. They can be a planet if they have tacos. If they don't have tacos, they're not a planet.
Oh God, that makes things so simple.
Right?
That means we live on the only known planet. If we're going by the
For
taco
now.
corollary.
There needs to be another term in the Drake equation for the probability of there being a taco on that planet.
Oh my God, that's it. I actually have the Drake equation just drawn up really pretty. I wanted to put it on a t-shirt. Now I think I'll make a taco version. Does it have tacos?
Well, you're looking for advanced civilizations, and how advanced can you be if you don't have tacos?
I mean, civilizations, I assume, get hungry.
Surely
I don't know. I don't know.
Oh man, this has been our first official. After the pilot, this has been our first official episode
Yeah,
of Science Actually Presents the Nerd and the Scientist.
I think. Yeah, I think my that vision I had of the two judges from the Chris Guest movie Best in Show, the two judges being us. I think it's freaking brilliant. I think it's spot on. I'm clearly Fred Willard. I got the stupidest shit to say, and Kavi just like rolls his eyes and like incredible amounts of patience. Like, yes, just like the hot dog thing. Supernovas are like hot dogs. Yeah.
If we didn't already have such a brilliant name for this show being Space into Face, it would be Supernovae are like hot dogs. That would be the subtitle for this
Subtitle.
episode.
That'll be the tagline. Space in the face. Supernovas are like hot dogs.
I love it.
Actually, supernovas are like sandwiches. And type 1A is like a hot dog.
Open sandwiches. Great. Well, for anybody who's still listening to this ranting, you have been listening to Science Actually Presents the Nerd and the Scientist. Tell them where they can find us, Benjamin.
Please feel free to find me. I run Science Actually on all the time wasters. Facebook.com/actually science is the big one, but you can find me on everything else: Twitter, Instagram, Threads, Blue Sky, TikTok. It's on LinkedIn if for you professional types. Gavi, how about you?
Yeah, we're nothing but professional. You can find me at Fun Fact Science on all the good procrastination apps and even the bad ones. Facebook, TikTok, the artist formerly known as Twitter, Blue Sky, Instagram. I might be on Mastodon. I don't remember if I'm on Mastodon, but I might be there. And feel free to look us up. Feel free to comment on these episodes. Tell us more about what you would like to hear. If you want to hear about a particular topic in science or nerddom, please let us know.
Feel free to message us
if you
on
want
any platform at any time. We want to hear more from you. We want to make you guys happy. And if we hear nothing, that means you're perfectly content with the supernova hot dog conversation, and we'll just keep that going.
I think my office mate is maybe less than pleased with that conversation, but
why?
I can see some eye rolls.
Oh, really?
Yeah.
On my own speaker.
But this has been great.
This is great.
This has been awesome. And I look forward to seeing you, Benjamin, and to seeing you, our audience, on future episodes of Science Actually Presents the Nerd and the Scientist.